learners, welcome to the today's topic. Our today's topic is problems related to hierarchical and lattice structure of attributes in warehouse dimension. In that we will take the dimension, time and location. Myself Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So I am going to cover the topics today. Today I'm going to cover the data warehousing modeling. So what are the modeling is there? In modeling, all the lattice will come, cuboids will come. How we are going to see the, we can say hierarchy concept, hierarchy of that. How the cuboids have been created if that is more than 3 dimensions. So what are the dimension we will take for that? And how we are converting it is a data cube. And later I'll give a example, give a problem, and I'll tell about the solution. So what is data warehousing modeling? First I'll give the basics, then we will go into the problem. So data warehouse and OLAP tools, it will be based on the multidimensional data model. So the multidimensional data model that can be seen in the form of data cube, right? So what is data cube actually? Data cube is nothing but data cube allows data to be modeled. So the logical view of the data we can see, the modeling of data we can see. So we can see that modeling into the form of multiple dimensions, right? So it is defined as a dimensions and fact. So dimensions will be there in the form of we will have the columns, and facts will be there. Facts will be the central table to associated with that particular dimensions. Now what a dimension? Dimension is nothing but dimension is the perspective to with respect to the organization, with an organization wants to keep the records. So particularly dimension is a relative perspective to see about the what are the class labels are, what are the dimensions are there related. Each dimension may have a table associated in it because there will be fact. So that will be the central table of that. So there will be the dimensions, and the table will also be related to that dimension table. So that particular table will be called as a dimension table, which further describes the dimensions. So the dimension term that is associated with the dimension table. For example, a dimension table for item. Suppose one dimension is their item that may contain the attribute, that there can be attribute related to item, the item name, what is the brand of that, what is the type of that. So that will nothing but that will be the dimension and dimension attributes. Now, a multidimensional model that is typically organized around a central theme. So there will be a central table also that is called as a fact table. So that will call as a fact table. That will be, suppose for this example, for sales, there will be the sales will be the particular central theme of table. So that would be represented as a fact table. So fact will be fact data. So there will be the sales. So sales is nothing but sales will be called as a measure. So that will be called as a fact also. That will be in the form of numeric values, right? So the fact table contains the name of fact, or we can say measure, as well as the key to each of the related dimension table. So the fact table will be in the between, that will be the fact table, and surrounding so many dimension tables will be there. Suppose this is dimension 1, dimension 2. So that all will be associated with this central table, that is fact table. So that will have all the dimensions written over there, right? And the dimensions related, what are the attributes are there, that will be stored into the dimension table. Now, the problem is that we have to find out the hierarchical and lattice structure of the attributes. So what are the attributes are there for particular dimension? For that we have to find out the lattice structure as well as the hierarchical structure, that is called as a concept hierarchy. So in the warehouse, the dimension we will take for that, suppose one example is there, the one data table is there, all electronics, that is a famous table. So that we will take, in that we have to take the dimensions, location as well as the time, right? So for example, if this table, all electronics table is there, that can create a sales data warehouse. So the related sales data warehouse can be there in order to keep the records of the store's sales records, sales figures with the respect of location, time, branch, and location, time, and branch and item. So there will be the 4 attributes can be there for sales, because all electronics is purely related to the store. So store will be the from the store the purchasing and purchasing things will be there. So on the basis of that we can assume sales data warehouse can be there and related attributes can be there for our understanding. So particularly in the right hand side we can see one table is there, that is a relational schema for the relational database, that is for all electronics. So in all electronics there are the dimensions: customer, item, employee, branch, purchases, item sold, and works at. So these are the 7 dimensions are there. So in that we have to take the location as well as the time. So location is, where is location? So particularly it can be there in the other table. So these are the main dimensions are there. So on the basis of that the particular attributes are there, that is customer ID, name, address respective to customer table. Like that the item, in item the item ID, brand, and particularly so on other attributes are there. So like this we are having the 6 dimensions. So in examples of there will be the facts, that will be the central table, because in that all the related dimensions will be stored. So the fact table will be the sales data warehouse here. So for the sales data warehouse we are having the dollars sold, in that sales amount in dollars, these are the 2 attributes related to the dollars sold. There are units sold, so there would be the 1 attribute, number of units sold. There would be the amount budgeted. This is the 3rd attribute of sales data warehouse. So like this we can see the 2D representation of that particular table that we have seen in earlier slides. So in 2D representations the sales of Vancouver. So from that table, that is the extendable table. From the extendable table we have to take the relative term. If we are in the location, if we are prompting for Vancouver, so here the query is written as a location is equal to Vancouver. So this is the particular query. On the basis of that there will have the in the respective to time, and we can say this is the sales figure. So in the respective to time there is a 2D view of sales data for all electronics according to the time and item. So these are the items. These are the items: home entertainment, computer, phone, security. Yeah, sorry. So in respective to item, as per as we have to take the 2 dimensions, item and time. So on respective to that, for the location Vancouver, we are having these sales figures for the respective facts, respective measures. So this is a 2D view of sales data for all electronics data set respective to time and item. So in this, sales for Vancouver are shown with respect to time dimension organized in quarters. So there are Q1, Q2, Q3, Q4, 4 quarters are there, and item dimensions that has been that has been organized into the form of types of items sold, that is home entertainment, computer, phone, and security. So these are the type of items sold. So in respective to that, the 2D representations of sales data set is this. Now the facts and measures will be displayed. So here the fact or measure displayed into the form of dollars sold. So dollars sold, here we can see the location is for 4 of the cities. So first is Chicago, New York, Toronto, and Vancouver, right? So in respective to item, and that is time. So that is the whole of the data set is there. So this is the 3D view actually of that particular sales data for the all electronics according to the time, item, and here we are taking the third we are taking the third dimension, that is the location, right? So that is nothing but that is a 3D table, that is a logical table actually. So in terms of that, all the we can say facts will be stored like that. Facts or measures will be stored like that. So here the dollars sold will be in the form of this is the fact. All are the facts or measures. Facts, or we can say measure, that is stored in the particular one cell. So in each cell there will be the figure. So that would be the dollars sold. So that is the type of dollars sold. That is in thousands. So $1,000 like this. So that is for understanding what we can see in this 3D logical data table. So now suppose that we would like to view the sales data, right? We would like to view the sales data with the third dimension. So for the third dimension, we have to take the location. So for instance, suppose we would like to view the data according to time and item as well as with the location. So for the city, Chicago, New York, and Toronto, and Vancouver, these are the 4 cities. Time and item is there. In time, there would be the 4 quarters, Q1, Q2, Q3, Q4, and item, all the related sold items will be, types of the items sold will be there. Now, suppose that we would like to view our data, sales data. Suppose we would like to view our sales data. So, we have to do it with the other 4th dimension. So other 4th dimension is nothing but if we are taking it as a supplier. So that is originally the 3D view. Now we can assume 4D view is also there. So that will be the hypercube. So, right. So for the 4th dimension, that is supplier, how we will going to view that particular data cube, and what will be the data representations of the 4D data cube, we will see. So next, the viewing these things, what I have said, 4 of the dimensions, we can see time, item, that other one is location, and what we have taken now for the 4th dimension, supplier. So these are the 4 dimension if it is there. So viewing the things in the 4D, that will become tricky because we would not understand what are the facts or measures is stored and related to which of the particular data cell. So however, we can think of a 4D data cube. So 4D data cube as being a series of 3D. So suppose here is the table of the 4D data cube, representation of that. So suppose in the earlier, what were the earlier 2D representations were there, 3D representations there. So that all the facts or measures that has been stored here, relative. So I'll show you. One second. So these are the item related to home entertainment, and in the with the respect of Q1 time quarter, so that is 854. So these all the facts or measures will be restored into the form of data cube. So in the data cube, if we are taking the 4th dimension, so how we can see that. So suppose there would have the, we have seen 854, so that is here. So like this, all the facts is related to here. But we can see here for the Venkar, if suppose city is Venkar, so there is no any relative facts or measures are there. Again in this dimension, in this nothing is there, in this nothing is there. So in the XYZ cells nothing is there. So that is particularly the 4D logical view of the same all electronics data facts. So here we can see here, so this is the item, item is type of home entertainment, computer, phone and security. So these are the 4 dimensions in the we can say front view. On the other hand, we have location city, we have this, what is this, time, quarter. So time is in the form of quarter. So like this, all the representations facts will be stored here in the form of data cubes. So that is suppose this is the logical view. So 4D data cube is often we can call it as a cuboid. So it will also be called as a cuboid. So given a set of dimensions, we can generate a cuboid for each of the possible subsets of the given dimensions. So here how we have generated the items and the facts, like this we can generate it for the other dimensions. So how many dimensions are there? For that we can generate the cuboid. Now in this form, the result would be a lattice of cuboids. So we have seen the cuboid for the particular time, location and supplier and dimensions. So but here the result it can be seen in the form of, that is a actually lattice of cuboid, making up the 4D data cube for item, time, location and supplier dimensions. So that all the cuboid, data cube, the data facts that will be stored, that will be viewed in the form of a structure, that is a lattice. We can have the logical view of that data cube, but how it is going to store, how it will be relative to each other, it is in the form of that lattice of cuboid. So that is a lattice of cuboid. The lattice of cuboid can also be called as a data cube. So either we are taking the data cube, either we can understand about the lattice of cuboids. So that will have the data at different levels for summarization, or we can say for the group by. We can also merge some of the dimensions with each other. So the following figure in the right hand side, we can see that is forming a data cube for the dimension item, time, location and supplier. Now the cuboid that holds the lowest level of summarization, that will be called as a base cuboid. So in this right hand side lattice of cuboids, we can see there is a point all, there is a point time, there is a point time comma item. So like this, there are so many points are there in the structure of 4D, but that is stored in the form of the lattice, but that all the levels will be there. In what level we can see what are the dimensions. So in the lowest of the we can say view, we can see the 4D, that is base cuboid. In the next we can see the 3D cuboid, next we can see the 2D cuboid, next we can see the 1D cuboid. So that will be the hierarchy of levels, and the last will be the OD, that is apex cuboid. There will be the no any dimensions will be there. Now for example, the 4D cuboids in figure 3, if in this figure right hand side we can see that this is the 4D cuboid of the other 4 of the dimensions, that is time, item, location and suppliers. So here the base cuboids, what will be the base cuboid? That will be the items in the last of the 3D cuboid. So that will be the 3D cuboid base cuboid. So like this we can understand for the supplier, when supplier is equal to supplier 1, so that will be the representations of base cuboid this. For the suppliers 2, supplier 3. So like this the base cuboid will be that will be the apex cuboid. Like this in the figure 1, if we have seen in the figure 1, so there were the 3D cuboid. So that were not the non-base cuboid. So that was the non-base cuboid for the item, time, location, and for the 3 of the dimensions for the all of the suppliers. But the 0D cuboid which hold the highest level of summarization is called as a apex cuboid. So that will call as a apex cuboid. So that is a terminology of that. The apex cuboid is typically denoted by all of the 4 dimensions. So that is having the all of the 4 dimensions. In our example, this is the total sales, or we can say dollars sold. So that will be summarized over all the 4 dimensions. So what are the dimensions? Item, time, location, and supplier. So like this, all the dimension has been summarized here in the form of base cuboid, 0D cuboid, apex cuboid. Now we will see how we can see the hierarchical structure. So what is hierarchical structure? That is nothing but that is having the hierarchy, concept hierarchy of that particular lattice. So the concept hierarchy defines a sequence of mappings from a set of low level concept, and that is having to the higher level concepts and more general concepts. So that will have the higher to lower and all other related concepts. So that is a sequence of mappings. Actually it is so like a T structure. In the right hand side we can see a concept hierarchy for location dimension. So that is a location dimension. So here in the right hand side we can see the location. For the location, and first we can see apex cuboid is all next country, next province or state. I am telling you it in the downwards state, but it will we have to start from the city. So like this, we have to start for the any lattice representation and any other representations. So basically it will start from here, right? So for the location, all of the hierarchy is there. So related to that, all of the city are there, all of the country are there, all of the states are there. So all will have the all of the 4 dimensions structure. So like this the concept hierarchy looks like. It is a mapping of sequence. So consider the concept hierarchy for the dimension location in the right hand side. The city that is having the values for location including Vancouver, Toronto, New York, and Chicago. So like this, for the one city value we are telling this, these are the 4 locations value are there, city values are there, right? So for the each city, for the each of the city, this is the first city, this is the second, like this, so many cities are there in between for this concept hierarchy, because we cannot represent all of the city names related to here in this we can say in this slide. But I have shown you what are the basically main cities are there. I have shown you. So that can be the cities that can be mapped to the province or state to which it belongs, like this, right? So for example, Vancouver can be mapped to the British Columbia and Chicago to Illinois, right? So like this the hierarchy will be followed. So the province and state can in turn be mapped to the country. So now that will be mapped to the country. The province and state will be mapped to the country. So that is Canada or US. So to which they belong, right? So these mapping from a concept hierarchy for the dimension location, mapping a set of low level concepts. So that is low level concept is city actually, I have told you. And higher level, what is higher level? That is country. So higher level, more general concept, that is country. So country are what is other related other dimensions will be there, that will also be mapped in this concept hierarchy. Now the meaning of the concept hierarchy are implicit within the database schema. So that will be implicit in this database schema. Suppose for example the dimension location is there, right? So that will be described by attributes, that is number, street, city, province or state, zip code and country. So these are the 4-5 attributes will be there. So like that will be implicit in within the database. So here we can see we have used city already, city, province already, country already. So but that will be implicit within the database. Now we want to see the what we want to see the lattice structure, but here we will see the hierarchy for one of the dimension, the lattice for one of the dimension. So how it looks like. So in the right hand side we can see the hierarchical and lattice structure of attribute. That is, first is that is the A, that is hierarchy of for location. So what will be the hierarchy for the location? That will comes from first will be the street, that will start from the street, that is a low level of the that particular dimension. Street to city, city to province, state that up to country. So that will be the highest level of that particular hierarchy. Now if we want to see the lattice structure for the time, only for the one dimension time, so what will be that? So that will be starting from the day. So that the day can be divided into the form of week, or we can say month. So directly we can go to months, or we can directly go to into the form of week. Week will be that will be related to year in the last, but from the day that will be related to months. Again months will be divided into quarter, that also will be subdivided into the year. So that will be the lattice structure for the time dimension, right? So these attributes are related to a total order. So that is forming what is. So concept hierarchy would be written in the form of double quotes, street, like this symbol, city, province, state and country. So the concept hierarchy will be for the that lattice structure for the location, this, right? So we have to write like this, and we have to draw the structure like this for the location. Now this hierarchy in the shown figure is alternatively for the attributes of a dimension, that may be organized into the form of partial order, that is forming a lattice. So for example of a partial order for the time dimension, that will be based on the attributes, that is day, week, month, quarter and year. So how we can write this? We have to write this is in the form of day. Then we have to combine that. So that like month, quarter and week, that will be combined into the one square, the curly braces. Now the last level will be the year. So like this we have to write the lattice structure for the time dimension. So that was actually for the time dimension. That is for time dimension. That is for location dimension. So like this we have to draw these of the lattice and hierarchy for the other dimensions. So that was now we will show how the concept hierarchy, the total concept hierarchy will be looks like. That will be the we can say broad view of the hierarchy. So the concept hierarchy, that will be the total or partial order among all the attribute in the database schema, that will be called as a schema hierarchy. So in the right hand side we have the concept hierarchy for the price. So that is basically a schema hierarchy. Concept hierarchy may also be defined as by the criticizing or grouping values for a given dimension or attribute. So what we have, I have told you earlier, that will that two of the dimension can also be merged at a place, that will be called as a grouping values for given dimension or given attribute. So that will be related, that will be resulting into form of set grouping hierarchy. So that will be called as a set grouping hierarchy. Now, a total of partial order can be defined among the set of group of value. So that is nothing but the set of value of set of dimension attribute. Now, for example, of a set grouping hierarchy, for the set grouping hierarchy, we can see in the right hand side, that is nothing but that is a concept hierarchy actually. Concept hierarchy for the price dimension. So there would have the some combinations of we can say hierarchies. So here we can see here in this branch we can see this is the merging of the sum two of the dimensions, related dimensions. That will be the grouping of hierarchy, grouping of dimensions. So here in the set group hierarchy that is shown in this figure, that for the dimension price, so where the interval $x to $y, that is denoting the range of the $x is exclusive and $y is the inclusive. So that all the related facts and measures have been represented here, but in between the sum of the labels we cannot show in this slide, so that is dotted here. So like this, the all of the set grouping hierarchy will looks like this in the right hand side, concept hierarchy for the time. Now there may be more than one concept hierarchy also for the given attribute or dimensions. So some of the time that can also have the more than one concept hierarchy, right? So based on the different user viewpoints. So basically this lattice structure, what we are calling the concept hierarchy, that only depends on the user's viewpoints. So because if I am going to tell this is I am viewing this structure in this form, some other person that can have the another view of that same structure. So that will be depend on to the person to person viewpoints. So the concept hierarchy can be more than one also. So for example, a user may prefer to organize the price defining ranges by inexpensive, moderately priced and expensive. So if one person is there, he have to bifurcate the price into the three of the forms. First he have to bifurcate that into the form of that price is expensive is there, second is moderately priced, so that is a medium price, and that will be the expensive, that will be the highest price. So like this also the user to user can have think of at particular we can say dimension. So like this there can be the more than one hierarchy also can be there. So concept hierarchy allow the data to be handled at varying level of abstraction. So what we have seen, the concept hierarchy is nothing but that is the particularly the logical schema is there, the logical view of the we can say data is there. So we can say it is in the form of abstraction. So that can be varying the levels of abstraction. So that was all about the today's topic. Here we have covered the problems on multi-dimensional data cube, 3D and 4D cube for the lattice structure and hierarchical structure, that is nothing but the concept hierarchy. So for that we have taken a problem that was having the time, item, location and supplier, and for that we have seen the different concept hierarchy, and we can see the lattice structure for that. So that was all about the today's class. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.